What if I told you that the universe you think you live in is real, but the universe that actually exists is so much larger, so much heavier, and so much stranger that your brain has quietly been voting against it your entire life? If this video makes you rethink something you believed yesterday, hit the like button right now, subscribe to the channel, and share it with one person who still thinks space is mostly empty. By the end of this story, you will want to talk about it. A telescope the size of a tennis court is floating right now, 1.5 million kilometers away from Earth, anchored to a quiet gravitational balance point in deep space, where the pull of the sun and the pull of the Earth cancel each other out. This holds a delicate instrument perfectly still. It is not pointing at Mars. It is not chasing headlines. It is not trying to take a pretty anniversary photo. It is staring, with the patience of a saint, into a patch of night sky roughly the size of 3 full moons held up against the darkness. It logged 255 hours of exposure across multiple observation sessions, broken into carefully timed windows. This was so its instruments would not saturate, and when the data finally streamed back to Earth, it did not bring back a postcard. It brought back the positions, the shapes, the distances, and the physical properties of nearly 800,000 galaxies. Not stars, not planets. 800,000 entire galaxies, packed inside a patch of sky the Cosmos Webb team describes as roughly the area of 3 full moons. And here is the part that breaks most people's mental models. Well, that number came from a region of sky so small you could cover it with your palm. That is the Cosmos Webb Survey, the largest general observer program ever approved for the James Webb Space Telescope in its first year of operations. The data set it produced is the deepest, widest look at cosmic structure humanity has ever assembled. But the number alone is not the story. The real story is what that number does to every model we built before Webb existed. The script is not going to list facts at you. It is going to walk you, slowly, through the quiet collapse of an old picture of the cosmos and the morning light of a new one. This picture arrived faster than we were emotionally prepared for. Stay with me. The view from here is genuinely different. To understand why 800,000 is shocking, you have to know what we used to think was hiding in that same region of sky. In 2004, NASA released the Hubble Ultra Deep Field. It was a million-second exposure, stitched together from hundreds of orbits and frames. It was celebrated for years as the deepest view of the distant universe humanity had ever captured. In that famous image, scientists counted roughly 10,000 galaxies inside a patch of sky about the size of a grain of sand at arm's length. 10,000 was treated as an extraordinary number. Astronomers wrote papers about individual galaxies inside that image. Teachers printed it on classroom posters. It became one of the most reproduced scientific photographs in human history. It stood alongside the pale blue dot and the pillars of creation, and it was profoundly, systematically incomplete. We just did not have the instruments to see how incomplete it was. The physicist, Caitlin Casey, described the scale jump with a comparison. If you printed the Hubble Ultra Deep Field on a standard piece of paper, the Cosmos Webb image would need to be a mural 13 feet wide and tall. That is not a small upgrade. That is the difference between seeing a single street corner and seeing the entire continent the city sits on. And the Cosmos Webb image is not just bigger in coverage, it is 10 times denser with detected structure than previously predicted. 10 times more galaxies than expected. Not 10% more, 10 times. When a measurement is off by a factor of 10, you replace the model. Something fundamental was wrong with how we imagined the early universe was populated. Webb's infrared instruments saw through the wall. The picture rebuilt itself almost overnight. So before we go further into what those galaxies look like, let me invite you to support this channel. If you're feeling that quiet vertigo that hits when the universe gets bigger than you expected, this is the place where that feeling gets an answer. Subscribe and turn on the bell. You do not want to miss the next one. Why were those galaxies invisible for so long? The answer is not mysterious. It is one of the cleanest illustrations of how physics quietly chooses what we are allowed to see. Light from ancient, distant galaxies does not arrive looking the way it left. The universe has been expanding since the Big Bang. As space itself stretches, the light traveling through it gets stretched along with the space it crosses. This is the Doppler effect for space. This is the same effect that drops the pitch of a siren, except it applies to the fabric of the cosmos itself. It has been running for 13.8 billion years nonstop. The longer light travels through space, the more its wavelength gets pulled. It moves toward the red end of the spectrum. Very ancient light from the first few hundred million years does not arrive as visible light. It arrives as infrared. Imagine an entire city of lights at night, all of them lit, but the window you are beside only lets through one color. For most of the 20th century, the window into deep space was that narrow band of visible light, plus a thin slice of near ultraviolet. Infrared light is heat radiation, entirely invisible to human eyes, until Webb. It was essentially invisible to our best space telescopes. The Hubble Space Telescope was an optical marvel. It was optimized for visible and near ultraviolet light. It could detect a narrow band of near infrared, but it could not reach the deep infrared bands where the oldest and most distant galaxies had their light shifted by billions of years. Those galaxies were not missing because they did not exist. They were missing because the instruments we built could not hear their frequency. Think of it like listening for whales in an ocean that absorbs every low-frequency sound below a certain depth. The whales were singing the whole time. We just did not have a microphone that could pick up the song. Webb was designed from its very first sketch to hear exactly that frequency. Its 18 gold-coated mirror segments collect more light. Arranged across 6.5 meters of width, they collect more than 6 times as much light as Hubble gathers. Its infrared instruments are sensitive to wavelengths Hubble could never touch. Webb turned those instruments toward sparse regions. The darkness overflowed with structure that had been there all along, lying in wait for a telescope capable of actually seeing it. This is the part of the Webb story that goes beyond science. Every image ever taken before Webb was missing most of its population. Every deep field, every galaxy catalog, every simulation was calibrated to a thin, visible slice of reality. We built an entire model of the cosmos on top of that slice. The universe was not misunderstood because the math was wrong. The universe was misunderstood because the instruments could only see a small fraction of the light the universe was sending. That distinction matters because it tells us something honest about the limits of human knowledge. The cycle does not end. Whatever telescope comes after Webb will probably do the same thing to Webb that Webb just did to Hubble. Now here's where the story turns from impressive to genuinely uncomfortable. The Cosmos Webb survey is not the only result rattling the old picture. Webb has been delivering a second, deeper surprise in parallel, and this one has been generating increasingly urgent debate. Think of cosmic history as a calendar year. The Big Bang is January 1st at midnight. Our universe today is December 31st. The earliest galaxies should look like shy seedlings pushing through cold soil. Small, dim, irregular, just barely lit. The accepted model of how the universe grew up is called lambda CDM, and it describes a slow, graceful process. Nearly uniform hydrogen and helium gas slowly collapses under gravity. The first stars ignite inside small, irregular protogalaxies. Those small galaxies grow gradually over billions of years through mergers and steady accretion of new gas. Eventually, they become the large, organized spiral and elliptical galaxies we see around us today. That model makes specific predictions. It tells us how bright galaxies should be at each cosmic age. It tells us how massive they should be and how chemically enriched. Webb keeps finding galaxies that violate those predictions. In 2024, a team using Webb NIR spec confirmed a galaxy cataloged as JWST Z140. It was found at a redshift of about 14.32, confirmed in peer-reviewed work published across major journals. That redshift corresponds to roughly the first 300 million years after the Big Bang. This is not a small, dim smudge. It is spatially resolved, meaning science can measure its actual physical size and shape. It is extraordinarily luminous in ultraviolet light. This means it contains a serious population of massive energetic stars burning through fuel at an alarming rate. And its spectroscopic signature reveals the presence of oxygen. That detail is small in sentence and enormous in implication. Oxygen cannot be produced by the Big Bang. Oxygen can only be forged inside stars through nuclear fusion. It can only escape into surrounding gas clouds when those stars die and explode as supernovae. For a galaxy to have measurable oxygen 300 million years after the universe began, entire generations of stars had to already be born. They had to burn through their fuel, explode, and scatter their enriched material back into the surrounding gas. They had to seed that gas with heavy elements, all in a cosmic window the standard model described as too short. The timeline is not slightly inconvenient for lambda CDM. It is tighter than the model comfortably fits. And JWST Z140 is not the only problem. Other early universe surveys have reported additional bright galaxies at extreme distances. The early universe is not just slightly more crowded than expected, it is more mature than expected. Something is off in the timing. At this point in the script, I want to ask you directly. If you have been following along this far, drop a comment with the word bigger. It tells me these breakdowns are reaching the right people and tells the algorithm to put this in front of more curious minds. Now, a few words on what science is actually doing about this, because what is happening behind the scenes is far more interesting. No peer-reviewed consensus has formed around the claim that the standard model is wrong. Cosmology does not move that fast. What has formed is a growing body of evidence that the standard model's predictions need significant revision or entirely new physics. Some astrophysicists propose that star formation in the early universe was dramatically more efficient than the models predict. Others point to possible roles for dark matter behavior in the early universe that current models do not capture accurately. This includes exotic possibilities for how dark matter clumps and seeds the first galaxies. A smaller group argues for fundamental changes. This might involve a refinement of how we treat the very first generation of stars, sometimes called population 3, or how we understand the timing of cosmic dawn itself. The scientific community is working through these possibilities methodically. Webb is generating new data to test them every single month. The point is not that cosmology is collapsing. The point is that cosmology is growing to fit observations that are no longer incomplete. That is how science is supposed to work. The third revelation is the one that requires a moment of quiet. The universe that Webb is now showing us is not the whole universe. It is not even most of it. It is the fraction of the universe from which light has had enough time to reach us since the Big Bang. Picture the surface of a pond. When you drop a stone into the middle, ripples spread outward in every direction across the surface. Any observer floating on the pond can only see the ripples that have reached them, not the ones still spreading beyond. We float in the middle of our own cosmic pond, and the ripples have been spreading outward for 13.8 billion years. The observable universe is a specific sphere of space centered on Earth. It is the bubble inside which ancient light has managed to cross. This light, traveling at the fixed speed of 300,000 kilometers per second, has crossed the distance to our instruments. That boundary is called the cosmological horizon, and it sits at roughly 46.5 billion light years in every direction. That number is larger than the age of the universe because space itself has been expanding the entire time the light was traveling. The light that left a galaxy 13 billion years ago has been carried outward by the expansion of the underlying space. So the galaxy, whose ancient photons are only now arriving, is currently estimated to be about 34 billion light years from us. This is far beyond the distance its travel time alone would suggest. The cosmological horizon is a boundary of observation. The universe does not end at 46.5 billion light years. That is simply the edge of what any telescope will ever see. Beyond that horizon, the universe almost certainly continues, in directions no signal will ever reach us from. How far it continues is a question cosmology cannot answer from inside its own limits. Space was stretched to huge dimensions. The period cosmologists call inflation occurred in the first fractions of a second after the Big Bang, stretching space enormously. Some frameworks suggest the true universe is hundreds of times larger than the portion we can see. Others suggest it is boundless. The honest answer is that the observable universe is our prison of perception, not the totality of what exists. And nothing Webb can observe, no matter how powerful its successors become, will ever change that fundamental epistemic boundary. It is baked into the physics of light speed and the geometry of expansion. But here's the dimension that is difficult to sit with. The observable universe is not static. It is shrinking. Not because our telescopes are getting worse, but because of dark energy. Dark energy is accelerating the expansion of space. Pause on that sentence for a moment, because it deserves your full attention. Dark energy constitutes roughly 68% of the total energy content of the modern universe, according to refined measurements. It is driving space to expand at an increasing rate. As a result of that acceleration, distant galaxies are being carried away. Galaxies currently visible to us are moving from Earth at ever-increasing velocities. Some are already receding faster than light. This means any signal they send today will never, in any future era of the universe, reach us. They are observable only by old light. We see them because light left billions of years ago when the expansion of space had not yet grown fast enough to prevent the crossing. But those ancient photons will be the last ones we ever receive from those galaxies. The light they emit now is being carried away. It travels toward us, but will never arrive. The cosmic microwave background radiation will redshift to energies below detection. This faint afterglow of the Big Bang will eventually be lost to any conceivable detection threshold. The large-scale structure of galaxy filaments that Webb is now mapping in unprecedented clarity will eventually be invisible. Its constituent galaxies will have been carried far beyond the horizon. A civilization studying astronomy in the very distant future, tens or even hundreds of billions of years from now, they will look outward and see a much smaller, apparently isolated pocket. They will have no observational evidence of the Big Bang. They will have no visible galactic web. They will have no way to determine from the sky above them how enormous the cosmos actually is. They will live in a remnant. They will live in a cosmically isolated pocket with no way of knowing what they have lost access to. They will not even know it. This is the part of the Webb story that hits at a level deeper than science. It touches something almost existential. We're living in a cosmically privileged moment of visibility. The universe is structured enough and bright enough to see. For a brief window of cosmic time, a telescope can read back nearly its entire recorded history. Webb is that telescope, and we built it just in time. What Webb is accumulating right now is not just data for professional astronomers. It is the most comprehensive reading of the cosmic record that any intelligence has ever attempted during one of the last eras. The Cosmos Webb data is publicly released to any researcher in the world through the project's archives. It is open to all. The catalog of nearly 800,000 galaxies spanning almost all of cosmic time is documented, modeled, and downloadable. The cosmic web map, tracing the largest structures in the universe back to its first billion years, is published and under investigation. The impossible galaxies of the early universe are cataloged and being scrutinized by teams with decades of modeling behind them. Every new observation is being checked, double-checked, and cross-calibrated against the next. We are verifying everything. What comes after the observable horizon? What fills the universe beyond the last light that will ever reach us? What is the total scale of everything that exists? These are questions that no instrument will ever answer from inside our bubble. The universe is not just bigger than we thought. The universe is bigger than observation can ever confirm. Webb has shown us the true scale of the part we can reach. The part we cannot reach is, by definition, immeasurable. And the fact that we built a telescope that floats 1.5 million kilometers away from Earth is extraordinary. It sits on a delicate gravitational balance point called the second Sun-Earth Lagrange point, with 18 gold-coated mirrors. Unfolding like a flower in deep space in this particular sliver of cosmic history may be our most extraordinary achievement. We were alive when the window was still open. We built the key. And we are using it now while there is still something to see. Take a breath. Feel how small and how impossibly lucky you are to exist in exactly this era, with exactly these instruments, asking exactly these questions. Most civilizations that will ever exist will never get this view. We are one of the lucky ones, and we do not even know how rare that is. If that does not change how you feel about being here, on this small blue dot, looking out at the dark with curiosity instead of fear, I do not know what will. If you want to keep standing in the doorway with me, hit subscribe, drop a comment telling me which part hit you hardest, share this with someone who still thinks space is mostly empty, and I will see you in the next one.